few names that reverberate in the pantheon of famous space missions like Hubble, Voyager 1 and 2, and the Space Shuttle missions from Enterprise to Endeavour. But another name you might want to start including in that list is the International Ultraviolet Explorer, or IUE. It launched in 1978 to study the ultraviolet universe, and it was so effective and reliable that it worked 24 hours a day, 7 days a week for almost 19 years. The IUE had unprecedented flexibility for a space telescope, and that allowed it to make some major discoveries, including capturing the biggest, closest supernova in centuries. Many popular telescopes study the universe in visible light, but that really only gives us one perspective. Astronomical phenomena can emit multiple types of light, and each can teach us something different. For instance, cooler stars tend to glow in mostly infrared, but younger, hotter, and more massive stars tend to peak in the ultraviolet. Supernovas also shine really brightly in UV, so if you could observe the ultraviolet light, you could learn more about how stars form, develop, and die. Unfortunately, our atmosphere is really good at absorbing ultraviolet light, and while that's great for our skin, it also makes it hard to study UV from Earth. So if you want to see this side of the universe, you have to send your instruments to space. We started doing this in the late 1940s, and had flown several UV missions by the late 60s and early 70s. But none of them rivaled the International Ultraviolet Explorer. NASA, the European Space Agency, and the UK all collaborated on the mission, and in 1978, they launched it into a special kind of orbit. It was a geosynchronous orbit, meaning it traveled fast enough to keep up with Earth's rotation, so it always floated above the same spot. In this case, the Atlantic Ocean. And that was huge. In fact, the IUE was the first astronomical research satellite to be placed in this kind of orbit, because they're not easy to get to. With how the math works out, if you want your satellite to take a long time orbiting Earth, you have to get it farther from the planet. So here, to get an orbit 24 hours long, your satellite has to be some 30,000 kilometers away. That's almost 90 times farther than the space station, and it means you need a lot of fuel, and that your satellite has to be light and compact. But the payoff was worth it. Because of this orbit, the IUE was always in sight of ground stations on both sides of the ocean in the US and Spain. That meant someone could operate it 24 hours a day, and that allowed observations to be made in real time, which was a new and exciting ability for a space telescope. Most other telescopes are in orbits where they move relative to the ground. So they have windows of time where astronomers can download their data and give commands, and other windows where the telescopes are busy observing things. During those times, they can't be disturbed, even if there's something really interesting happening elsewhere in the sky. But IUE could be in constant communication with the ground, so if another telescope spotted something cool, it could follow up with UV observations within an hour or two. Like if, say, a star exploded in the brightest supernova in almost 400 years. That happened in 1987, and because we could point the IUE toward it so quickly, we got to catch a supernova exploding for the first time with a modern telescope. Because of this, we learned that the culprit was an exploding blue supergiant, not one of the more common red ones like scientists might have guessed. And further analysis of the explosion's light, plus some help from other satellites, also confirmed an idea scientists had held for a while, that supernovas with all their intense pressures and temperatures are responsible for creating most of the heavy elements on Earth. And that's really only the tip of the iceberg with this mission. Like earlier in 1986, IUE studied the famous Halley's comet along with a fleet of other telescopes, and its ultraviolet perspective caught a bunch of carbon dioxide ions flying off the comet. To explain this, researchers proposed that comets like this don't have homogeneous internal structures. Instead, they might have occasional internal pockets of volatile compounds. And when those compounds heat up as the comet approaches the sun, they might explode outward. The pocket in Halley's comet didn't realize a lot of material. The IUE only detected about 3 cubic meters worth. So overall, the comet is fine. But in other cases, the lead researcher here proposed that this mechanism could be enough to destroy a comet altogether. Over its years in operation, the IUE took more than 100,000 observations of almost 10,000 objects, including stars, comets, and galaxies. They've taught us how much stuff there is in the space between galaxies, that Jupiter has auroras, and how fast comets lose water as they approach the sun. It's a varied list because UV light lets you study that many phenomena, and for most of its lifetime, the IUE was our only way to observe ultraviolet light in the universe. So maybe unsurprisingly, thousands of research papers and more than 250 PhD projects have used data from the telescope, making it foundational to an entire generation of astronomers. Eventually, though, the telescope started to wear out. And with budget constraints and broken parts leading to increasingly complicated operations, the team decided to end the mission in September 1996. Today, it's been succeeded by things like the UV cameras on the Hubble and the Swift satellites. But overall, the IUE really laid the foundation for both modern UV astronomy and for long-lived international collaborations. So the next time you're listing off your favorite missions, consider this one too. And if you really want to show your love for this mission, hey, We made a pin! The IUE is our pin of the month for January, so all month long you can order one of these to attach to your favorite jean jacket, hat, backpack, or whatever else. Besides just being beautiful to look at, they're also an excellent conversation starter. If you want one, you can head over to dftba.com/scishow anytime between now and February 1st. Thanks!